Recursion is probably one of the hardest things to wrap your head around when you first encounter it. But what if I told you that recursion is not only quite easy, but also a powerful way to simplify complex problems? A lot of explanations I've found for recursion have been unhelpful, and it took me a few years before it really sank in. In this video, I'm going to talk about why recursion appears so hard, how to think recursively, what you'd actually use it for, and of course, we're going to write a recursive function. If you find this video helpful, please like, comment on, and share this video, and subscribe to my channel. This helps YouTube reward good videos. So why does recursion appear so difficult if it's actually very easy? There's a simple explanation for this. When you first learn how to code, you start by reading it line by line, like a book or a recipe. Beginner code has a linear flow, and it's easy to read because you're keeping track of one state at a time, and each line is a very straightforward change. Recursion represents a challenge to this way of reading code because it requires keeping track of multiple states at once in your head, something that humans are just not naturally very good at. Imagine cooking 2 or 3 recipes at once. A professional chef might be able to do it, but the average home cook or beginner chef might struggle. It's the same thing with recursion, and it'll become more natural with practice over time. If you understand the core elements of a recursive function, then you're already halfway to understanding how it works. So let's talk about its elements. Here's a very simple example of a recursive function called goHome. You give it a number of steps needed to get home. Let's assume it'll be above or equal to 0, and it checks if the number is 0. And if it is, we return, honey, I'm home. Otherwise, we call the function goHome again, but with one less step. So there are 2 parts to this function that make it recursive: the base case and the recurse case. So the recurse case involves the function calling itself with a different argument. If you call goHome with, say, 10, then when the function gets called again, it's going to run again with 9, and then 8, and then 7, etc., until we get down to the base case, which would, in this case, would be steps needed is equal to 0. That's the moment that the function can finally stop calling itself and return something useful. So this is effectively going to be looped until steps needed equals 0. So you might be thinking, wow, recursion is basically just a loop, isn't it? And if you are thinking that, then you're kind of right. A function powered by recursion could be rewritten using a while loop instead, also known as the iterative approach. This is goHome rewritten using that approach. Notice that we flipped the order of the logic, but this way is actually truer to how humans usually think through problems and sequence events. In real life, you don't think about whether or not you're going to say, honey, I'm home, while you're walking home. You say it once you get home. So if it's easier to write and understand a while loop, why would you ever want to make a recursive function? Recursion really shines when you're working with data and you have no way of knowing up front how large or how deeply nested that data is. And this makes it highly effective for tasks like navigating file structures, parsing JSON, and traversing complex data structures like trees and graphs. These types of problems will be more difficult, if not impossible, to solve using an iterative approach. So now that we've talked about recursion, its elements, why you'd use it, let's write some recursive code and I'll walk you through how it works. I am currently in my Chrome DevTools, and we're going to write some recursive code in JavaScript right here. I'm using Chrome DevTools because it comes with this handy dandy call stack tracker that I can use to show you how recursion works. If you want to follow along, just open up your DevTools, navigate to the Sources tab, click Snippets, and then click New Snippet. We're going to write a function that takes an array and returns the sum of all the numbers in the array. And the gotcha with this problem is that the array contains numbers and arrays. And those arrays could contain numbers and arrays. And those arrays contain numbers and arrays. And you get the idea. Basically, we're going to be dealing with potentially nested data. And recursion is going to provide a much more elegant solution that's easier to understand than if we were to do the iterative approach. So let's write the function, and we'll step through it and get a feel for how it works. So we're going to go function add all numbers is what we're going to call it. It's going to take a parameter. We're going to call it nums. So we're going to set up a sum variable just so we can keep track of all the numbers that we're adding up. Let sum equals 0. Pretty straightforward. All right, so next thing we're going to do is we're going to loop through all of the elements in this array right here for let num of nums. We're going to add whatever number we get here. So first we're going to just do sum plus equals num But of course, this could be an array. So what are we going to do here, right? Well, we're going to have the function call itself. All right, so that's going to look like this. First, let's check to see if it is an array. Is array num. If it's that, we're going to run the function that we're in right now, add all numbers, num. Otherwise, we're going to just add num, and then we're going to return our sum. That's it. There's only a few lines of code. All right, so now let's activate it. I'm on a Mac, so I'm going to press Command Enter, and there's my console down here. Oh, I don't need all of this. And now this function should be available in my console, add all numbers. I'm just going to copy and paste this. Obviously, feel free to use whatever data you want. I expect this to return 40, and let's see if it does. Yay, it does return 40. Awesome. Now let's go through this function one step at a time so that we can see what's actually happening in a recursive function. So in order to step through it one step at a time, I'm going to add a debugger statement like so. So bugger. Okay. I'm going to activate it like so, and then I'm actually going to make this simpler just so we can have fewer things to walk through, but the idea is going to be basically the same. I'll make it like this, 1 and 2. Yeah, 11 and 2, why not? We've paused our execution, we're on our debugger. All right, so now let's step through it one at a time. We start with our sum of 0. All right, so now we're going to start our loop. Our first num is going to be 1. Obviously, that's not an array, so that's going to be added directly to our sum. So, yep, now it's 1. So now the next number is going to be 2. That should be added to sum, and that should be 3. All right, and now the next num that we have is going to be an array, and it's just going to be 3, 5, 6. So that should give us a sum of 14. Because it's an array, we are going to call add all numbers. Okay, and so what that's going to look like is that we are going to add all numbers to our call stack. Okay, so that means whatever the result of this function call is going to be put into here once we get out of this function. We're on our second call of it, and we have a fresh argument, which is 3, 5, and 6. And again, this should give us 14, so we're going to loop through it. So sum is 3, and then 8, and then 14. All right, and then that should return it. And then this 14 is going to replace add all numbers with 14. Okay, and so now that should give us a sum of 17. All right, and so now what's the next num going to be? It's going to be 11 and 2, so that should give us 13. All right, so because it's an array, we are going to have to call this function again, and then yep, now we have it back in our call stack, and we are starting over with 11 and 2. Our sum is 0, and now we're going to loop through it. It's going to be 11, and then we're going to add that to our sum, and then the next number is 2. We're going to add that to our sum, and then we're going to turn 13. And then this is going to be replaced with 13. And the sum in the initial call stack is currently 17, I believe. Is it? Yep, it should be. And then, yep, and now we got our sum of 30. And so now we are on, what's it gonna be next? Oh, okay, I guess that's it. Yep, okay, I guess that was it. Cool. If you have any questions, definitely let me know in the comments. And if you found this video helpful, please like, comment, subscribe to my channel, share this video with anyone you know who might be struggling with recursion, and I'll see you in the next one.